So for chapter 10, we're going to look at radical expressions, and we're going to be graphing them. Let's go ahead and start with just the expressions. And why do we have radicals? The idea is that we need to be able to undo a squared equals 64. So we know what number times itself is 64. We go, yeah, the 8 times 8 is 64. But we need a mathematical operation that does that, and that is a radical or a root. So if I have a square root, to undo a second root, a second power, I use a second root. We put that, there is an implied little 2 in here. We're basically saying what times itself twice. To undo a second power, we use a second root. And if I do it on one side, we do it to the other. Now keep in mind, because right now we're not actually going to be solving equations like this, we're just going to be simplifying. But if this square root, if we put this square root here, okay, then what that means is we have to consider two possible answers, because there are two numbers that times itself makes 64. It could be 8, or it could be a negative 8, because 8 times 8 is 64, and negative 8 times negative 8 is 64. But the only time we have to put that, plus or minus, is when we put the square root. When we put a root in the equation, we have to consider both answers, okay? So in this, like I said, we're going to be simplifying. So if I just had the square root of 64, the answer to that would just be 8. Like, well, how would I know if I wanted a negative? Well, then they'd put a negative in front of it. The negative square root of 64 would be a negative 8. That's how they're going to handle it in section 10.1. And what is the square root of negative 64? Now that should stop you, because we're saying what times itself makes negative 64. Like, well, 8 and negative 8. Well, that's great, but we asked what times itself makes a negative. Well, there is no solution that's going to work for that, because we cannot have a positive times a positive make a negative, and a negative times a negative. But we don't just put no solution, because we will deal with this later. So what we put is we put that there is no real solution. Does that imply that there's some fake solution to this? Yeah, and we'll actually deal with that later, so don't stress out. But just for now, we're going to put no real solution when we have the square root of a negative. So what is the square root of a squared? Well, those are inverses of each other, right? We're literally saying, what is the square root of a times a? So since these are inverses, the inverse of an exponent of the second power is a second root. Remember, there's no 2 there, but it's an implied 2. This would just give us a. The same thing can be done with a fourth root. To undo a fourth root, we would use a fourth power. They are inverses, giving us just a. To undo a third root, we would have a third power, giving us just a. These are inverses of each other. We can pull out the groups. This we're pulling out groups of 2. There were 2 a's, so an a comes out. This one we're pulling out groups of 4. There was 4, so an a comes out. This one we're looking for groups of 3. There were 3, so an a comes out. In all of these, the root and the exponent are inverses. They cancel each other out. But they have to be the same number for them to cancel each other out. Okay. So the square root of 144, it should be like, okay, 12. The negative square root of 144, the 12 comes out, the negative makes the whole answer negative. The square root of negative 144. Well, what number times itself makes 144? Not going to happen this time, right? There is no number, no positive number times itself. There is no negative number times itself, so this has what again? No real solution. What is the square root of 4 over 9? Well, somebody's going to tell me 2/3. Well, good for you. You know that 2 times 2 is 4, 3 times 3 is 9. I'm okay with that. But that's not always going to work, so I'm going to encourage you to know that whenever we have the square root of a fraction, we can solve it by splitting it. What does that give us on the top? Well, the square root of 4 over on the bottom, square root of 9. Square root of 4 is 2. Square root of 9 is 3. You're like, well, I got the same answer. I understand, but the square root of 4 over 5 is not 2 over 2-point mess, right? You can't just put that and get a decimal. So we need to know that we have to be able to split these so that I can simplify what I can. Now we wouldn't leave that. We would multiply top and bottom and get 2 root 5 over 5. Okay? They're not going to do this at this point. I'm not expecting the square root of 4 over 5, but I just need you to know that the square root of a fraction, we need to know to split it. What's the square root of 0.81? Once again, somebody may logically go, well, I know 9 times 9 is 81, and to do decimal places, it would need to have 1. Well, good for you. Somebody else is going to go, I don't know, I got a calculator for this. What is the square root of 0.81? And it is going to give us 0.9. And I'm okay with that. Or, this is one where you can actually take it back to the fraction and make a little more sense out of it. The square root of 0.81, if you can read that with place value, what do I mean by that? Well, it's 2 decimals after or 2 numbers past the decimal place. So that would be tens, hundreds. This number is 81 hundredths. So, well, 81 hundredths can be written as a fraction. 81 hundredths is the same thing as 81 over. And what is the square root of 81 over 100? Well, split it. The square root of 81 is 9. The square root of 100 is 10. So our answer is 9/10. Isn't that the same answer we just got there? Like I said, we're going to have the technology, so that doesn't bother me, but it's interesting that that place value actually can help us in this situation. I will tell you, they will want the answer as a decimal in the homework. I would accept either of these. The square root of 16 we have no problem with. What times itself makes 16? What times itself makes 9? What times itself makes 13? Not sure. I know that it's 3 point something. Well, how do I know? Because that makes sense that the square root of 13, that 13 would be somewhere between 9 and 16. Therefore, our answer should be somewhere between 3 and 4. Because if the square root of 9 is 3, the square root of 16 is 4, then the square root of 13 falls in between those, 3 point something. So, and that's okay. I just understand that this is irrational. It is still a very real number. Okay, so if I do the square root of 13, oops, 3.605555. Why am I putting dot dot dot? Because that's not where it stops. See, if I go up to my calculator, I can hit that answer and get a few more decimal places. But it still doesn't stop there. This is a never-ending, non-repeating decimal. That is the definition of an irrational number. Okay, so we're going to have several types of numbers. We've already seen that if we have the square root of a negative, we call that not real. It is not a real solution. So the square root of a negative is not real. So, but the negative square root of 29, that is real. Because there is some number that times itself that makes 29. It just ain't pretty. See, I know that the square root of 29, sorry about that, let's clear that out. I know that the square root of 29 is somewhere between what two numbers? How about 5 and 6? How do I know that? Well, the square root of 29 would be somewhere between the square root of 25, which is 5, and the square root of 36, which is 6. So our answer should be somewhere between 5 and 6, probably closer to the 5, closer to the square root of 25. So we could check that. 5.38516, 5.385. And the negative on the outside makes the answer overall negative. Now it's a dot, dot, dot. You were going to round that off, but the idea is that this would be an irrational number. But is it real? Is that number times itself make 29? Absolutely. I can take that answer and I can square it. And it is 29. That number times itself is 20. Now keep in mind the calculator is keeping way more decimals than this for real. So if we did round it off 5.385 and we squared it, It's not going to be exactly 29. There's some round off error there. But the more decimals we keep, the closer we're going to get to the exact answer. Okay? And that is a real number. There is a real number that times itself makes 29. What is the square root of 5 squared? Well, just like earlier where we had 5 squared with the square root and they canceled and gave us a 5, because what? These are inverse operations. Well, there's still inverse operations here. This ends up just becoming 5. Like, I'm not sure. Well, this means what? Square root of 5 times the square root of 5, which is the square root of 25, which is just 5. These are inverses. They literally cancel each other out. What is the square root of 15 squared? What is the square root of a squared? Now, sometimes they will put like an absolute value of a as your answer. I'm not sure if this book does that. If it does, go ahead and kind of work through that in the homework. But this is the answer I'm wanting. Technically, if a was negative, this would not be true. So it's not an important A basket issue to me. So if the homework does this whole absolute value thing, I'm not as big on it. I just want you to understand that a root and an exponent, if they are the same, a second root and a second exponent cancel, leaving us with 2x squared plus 3. If this book has you put that in an absolute value, just do it for the homework. I'm not going to test you on that. Okay? Okay. So let's talk real quick about types of numbers. The square root of a, if the result is a whole number, like we had the square root of 4 is 2, the square root of 1/4 is 1/2. If our answer is a whole number, a fraction, or a terminating decimal, what do I mean by that? 1.333333, any decimal that terminates 0.9 or repeats. Sorry, I kind of erased some of my notes there. So terminates 0.9 or repeats. Why? Because any terminating decimal can be written as a fraction, and any repeating decimal can be written as a fraction. We call that rational. Anything that can be written as a ratio, anything that can be written as a fraction, is called rational. 2 can be written as a fraction, 2 over 1. 1/2 is obviously a fraction. 0.9 can be 9/10, 9 over 10. 1.333 is 1 1/3. Any decimal that repeats can be written as a ratio or rational number. Okay? If it doesn't repeat, non-terminating, non-repeating, like the square root of a is 3.65, that mess that we got earlier, right? That would be a irrational number. The square root of 2 is irrational. What number times itself makes 2? It ain't pretty. It's real. If I do the square root of 2, the square root of 3, square root of 5. If I do, what did we say? The square root of 2. Non-repeating. It starts to look like it's going to repeat, but if you go check, it doesn't. It's not 1,4,1,4, then it's 2,1,3. See, it's non-repeating. Same would happen with the other square roots. Non-repeating, non-terminating. This also includes something you've seen like pi. What is pi? When you're like, oh, 3 point, really? It keeps going. Non-repeating, non-terminating. Later on we use e, which I believe is approximately 2.17, but that is also a non-repeating, never-ending decimal. Let me check on the e real quick. E. Let me clear this out. E. 2.71. I'm a little dyslexic today, I guess. 2.718. All right. So, but what? It is a non-repeating, never-ending decimal. You're like, well, then that must mean they're not real. Actually, that's kind of crazy if you think about it. All of these values show up in nature. Pi shows up with circles, obviously. E shows up when we have growth and decay in nature. That ratio shows up. Square root of 2, square root of 3, square root of 5 show up in measurements. Any square tile you're looking at has a diagonal distance that is a radical. Okay? So the idea that these are not real is wrong. Anything that is rational, anything that is irrational is still real. Okay? We call it irrational. Literally, when we use irrational outside of math class, it means something that doesn't make sense. That's why early mathematicians were dealing with this, and a lot of them were wanting to call these numbers not real, but they kept showing up in nature. So what did they do? They said these numbers don't make sense. They are irrational. Doesn't mean they're not real. All of these are real numbers. You're like, well, how will I know if it's not real? Well, that's if I have the square root of a negative. That's not real. That is what's called an imaginary number. Okay? So the square root of 9. The result of that is 3. Just a whole number. So what is that? Well, can it be written as a ratio? Then it is rational. And if it is rational, it is very real. What about the square root of 7? Not a pretty number, right? Check that one in your calculator. The square root of 7. Sorry about that. Let's see, the square root of 7. Craziness. 2.645. 2.646 if I round it off. But it is a non-repeating, never-ending. That makes it what? Irrational, but still very real. Square root of 72. Hopefully you're getting it by now. 8 point something. Irrational. Still real. So what can we do with an irrational number? Well, it is real. We can still simplify these. Now the square root of 7 didn't simplify, but the square root of 72 would be the square root of, looks like 36 times 2. And the square root of 36 can simplify. That would just become 6 square root of 2. So the square root of 72, let's see, the square root of 72 can be simplified as the same thing as 6 square root of 2. And those are still the same irrational but very real number. Okay? Square root of 4 over 9. You're like, I don't know, this one doesn't make sense. It must be irrational. Well, no, that's not true, because what is the square root of 4? What is the square root of 9? Somebody's going to put this in their calculator, and they're going to just get 0.6666, and they're all, you know, of the devil and all that. But I'm looking at this going, wait a second. This would be a repeating decimal, which means what? It can be written as a fraction. Therefore, it is still rational. Oh, I forgot on the previous one. Even though it's irrational, it is still what? And when it is rational, it is still what? What is the square root of negative 43? That's craziness. First of all, square root of 43 is hard enough for us to fathom, but the square root of a negative immediately makes this what? Not a real number. Or we call it imaginary. Okay? So what about the third root? Well, the third root says, what times itself 3 times makes 8? Well, 8 is 4 times 2. Splitting that apart, 2 times 2 times 2. There are groups of 3. This time when I'm doing a third root, I'm looking for groups of 3. What times itself 3 times makes 8? Just a 2. What's the third root of negative 8? Like, oh, that's easy. It's not. No, that's wrong. It's not. We're not real. It is real. How is this one different than the square root? Because now we're not saying what times itself twice. We're saying what times itself 3 times makes a negative 8. That works. You can have 3 negative 2's make a negative. Therefore, our answer is just negative 2. The third root of negative 8 is just negative 2. What's the third root of 216? Not sure off the top of my head. I'm thinking maybe it's 6. 6 times 6 is 36, times 6 is 216. You don't have to memorize that. You can use your technology. Third root, you have to get a little fancier with your calculator. See, I have a button here that has an nth root. I do that, and I can do the third root of 216. Or I can kind of work my way through the calculator and see, but find in your calculator how to do a third root. What's the third root of negative 216? Hopefully you're not falling for it this time. See, if I go to that previous answer, and I change that 216 to a negative 216, my calculator still has no problem with that answer. What about a fourth root? What is the fourth root of 16? Well, 16 is 4 times 4, 2 times 2 times 2 times 2. I'm now looking for groups of 4. This has 4 things. So the square root of 6, or fourth root of 16 would be just 2. The negative fourth root of 16, negative 2. The fourth root of negative 16 is not real. How do we know? I cannot have 4 negatives make a negative. I can't have 4 positives make a negative. If it's ever an even root and we have a negative, it is not real. If we ever have an odd root, okay, if x is the odd root, so a third root, a fifth root, a ninth root, then the answer will be negative and very real. Okay, so even roots, any negatives in there are not real. Any odd roots, we can actually have an answer. An odd number of negatives makes a negative. Okay. Let's go ahead and talk about graphing here. Okay. So if I ask you to graph the square root of x, worst case scenario, you're like, I have no idea, but I can handle the algebra of doing square roots. Okay. Then pick some numbers. And you're like, well, what numbers? Generally negative 1, 0, and 1 give me a good start. So what do I do? Well, if x is negative 1, what is the square root of negative 1? Well, this is not real. That's okay. That just means the graph doesn't exist at negative 1. What's the square root of 0? Well, that's just 0. Finally, we got a point. What's the square root of 1? Well, that's 1. You're like, cool, it's just a straight line. Don't fall for that. Check some more numbers. And I can do 2. I don't recommend it. Why not? Because the square root of 2 is not a pretty number. See, it's a real number. I can do the square root of 2. The square root of 2 and get an approximate. Should be 1 point something. 1.4. So I can do 1.414 and go from here and go to 1.4. But that's not really terribly helpful to plot a bunch of messy points like that, right? So I'm going to pick numbers that have a square root. So square root of what? Well, 3 ain't pretty, but couldn't we do a 4? Then that would be the next x I would choose. Because the square root of 4 is 2, gives me a nice point, 4, 2. I hope you're seeing at this point, this is not a straight line. What does it look like? Well, it's curved. It's kind of like the top half of a sideways parabola. You're like, I don't know what any of that means. But don't worry about it. It's kind of like a curve. You're setting it up, and it's kind of leveling out. It never does quite level out, but it shoots kind of rockets to the right. Okay? So if I ask you to graph some more complicated square roots, what do? You go back to the parent graph. If this part confuses you, that's okay. You don't have to use parent graphs yet. But when we get to parabolas, you're going to need to know parent graphs and shifting. So I like to introduce it here. Worst case scenario, if this confuses you, just plot points. Use your technology. And then at least when we get to the parabolas where we need to know parent graphs, you'll be a little more familiar with it. Okay? So how do we graph? F of x is a square root of x minus h plus k, and I'm going to focus mostly on the h and the k. They'll do some stuff with the number in the front of the a, but I'm not as big on that. So let's deal with a couple things first. The a, the number in the front. What does the a do? It will always either stretch or shrink your graph. For instance, if I was to put a 2 in front of this graph, all it would do is make my y values twice as tall. Well, 0 would still be 0. 1 would now no longer be 1, it would now be 2, twice as tall. 2 wouldn't be 1.4, it'd be like 2.8. 3, 4 wouldn't give me 2, it'd be twice as tall. It would go all the way up to 4. It looks very similar to the same graph. It still levels out, but it's what? Twice as tall. If the a is greater than 1, it makes all the values twice as tall. If it's between 0 and 1, like a fraction or a decimal between 0 and 1, that will just shrink all the numbers by that ratio to make them shorter. So if it was 0.1, everything would be 10% smaller. If it was 0.5, it'd be, 50% smaller. So keep in mind that if the a is greater than 1, it stretches the graph. Between 0 and 1 would be basically shrinking the graph. What if the a is negative? All that does is make all the y values that we got a negative. So 0 would still be 0. 1 no longer would go up to 1. It would make it a negative 1. 2 would now go to negative 1.4. And 4 would now go to negative 2. The graph looks just like the other one. It's just been flipped. See, if an a is negative, it reflects the graph across the x-axis. It creates this reflection. It flips all the y values and makes the graph flip to the bottom half of the graph. Okay? Next. What does the k do? Well, if you're not sure, you can always plot points. What points? Well, kind of the same numbers we did. Negative 1, 0, 1. I'm going to skip 2 this time because it wasn't very helpful. So I'll put 4, but I'll get one more just for fun. We could do the square root of 9. Okay? So the square root of 0 is 0, square root of 1, square root of 4, square root of 9. This is the parent graph. Okay? What does this graph look like? Well, we could check. The square root of negative 1, this is still not real, so that changed. Okay? The square root of 0 is still 0, but now we don't just have 0, we have 0 plus 1, which is 1. The square root of 1 is still 1, but now it's 1 plus 1, or 2. The square root of 4 is 2, plus 1 is 3. The square root of 9 is 3 plus 1 is 4. All of the y values have been increased by 1. What does this k do at the end of the graph? It shifts the graph. It moves it up or down. If that k was a positive 1, it shifts it up. If it were a negative 1, all the y values would go down 1. So if I look at this, we got 0, 1, 1, 2, 4, 3, and 9 goes up to like 4. So what does this graph look like? It looks just like the parent graph. You're like, well, how do I know? Well, the parent graph was these points. What happened? All of those graphs, all of those points were shifted up 1. So I don't have to make a table if I know the parent graph. I literally could just make the parent graph and shift every point up 1. If you don't like that, then plot points. If you do like it, that's good because we're going to need this later for parabolas anyway. Okay? But that k is going to shift the graph up or down. Let me show you real quick, just so I'm not just making this stuff up. If my technology will behave, there we go. How about the square root? Square root of x. Okay, we saw that. We've wrapped that. If I make that the square root of x plus 1, it just takes that entire graph and moves it up 1. Same graph, just been moved up 1. If I changed it from a plus 1 to a plus 3, now it's just the parent graph moved up 3. This moved up 3, 1 moved up to 4, 2 moved up to 6. Everything got shifted up 3. And we said, what if it's negative? What if instead of plus 3, we did minus 3? Well, that would just take the graph and shift it down. Positive moves all the y values up. Negative moves all the y values down. Next, what does the h do? I'll give you a hint. If you're not sure, plot some points. Here's the problem. See, before 0 gave us 0. Here, 0 gives us the square root of 0 plus 1 is 1. Gives us a 1. That's interesting. 1 gives us the square root of 2, which we saw before was like 1.4. That's not very pretty. 2 gives us the square root of 3. That's not fun. 3 would give us the square root of 4. Finally, we got a nice number. That would just be 2. So I got some numbers. 0, 1, 1, 1.4, 2, didn't like that. 3 gave me 2. So what does this graph look like? And you're like, well, just like the parent. The difference here is negative 1 now exists. Why? Because negative 1 plus 1 would be the square root of 0. This is now 0. What about negative 2? So negative 2 plus 1, that would be the square root of negative 1. This is where the graph does not exist. This is where it is imaginary or real, right? So what happened here was this graph did not get shifted up or down. This graph actually looks just like the parent, but instead of starting at 0, these were the parent graph points. These are the parent graph points. 0, 0, 1, 1. There was the 1.4, and then 4 gave me the 2. Okay, all of these points got shifted to the left one. H shifts the graph horizontally, left and right. If H is positive, I don't know why I put a K there. If H is positive, the graph will shift, well, this just shifted to the left. That seems counterintuitive. You're like, well, wouldn't positive be right? No. It's opposite. The H shifts opposite. Why does it shift opposite? Well, because what makes a 0 here is no longer a 0. It's a negative 1. So this 0 was 0. Now all the y values basically got shifted to the left. 1. We have the same y values, 0, 1, and 2. They've all just been shifted 1 to the left. Something wrong with my brain. I'm sorry, the y values aren't left. Negative 1 gave us 0. Yeah, 0 gave us 1. And then I guess this one 3 gave us. So but basically they're all shifted to the left. Yeah, my brain's working. It's just a little off on this. What if H was negative? Well, then what would make a 0 would be moving the graph to the right. Like I said, if you don't like this, the worst case scenario is you're going to have to plot points until you get the graph. But I'm going to show this to you as well. The graph will look just like the parent. In fact, here's what I'm going to do. I'm going to get rid of this, and I'm just going to put, here's the parent. So what would happen if I did x plus 1? Well, we just saw, instead of 0 being at 0, negative 1 will make a 0. So it's going to be the same graph. Everything was just shifted 1 to the left. What if instead of plus 1, it had been plus 3? Well, now what's going to make a 0 is not at 0. It's going to be at negative 1, 2, 3. Same graph, just shifted to the left 3. What if instead of a plus 3, it had been a minus 5? Or just do minus 3. Same graph, but now what makes a 0 is 1, 2, 3. So that's where the graph starts. That's the 0. It just shifts the graph left and right. Worst case scenario, plot some points. We're almost done with this section. Last but not least, okay? So this is the parent graph for the square root of x. What do? We shift it to get a new graph. The h is opposite, shifts left and right. If it's positive, it's left. If it's negative, it's right. The k shifts the graph up or down, vertical. So if I have the square root of x minus 3 minus 2, this 3 right here is an h. The fact that it's negative means it will shift 3 to the right. This minus 2 is the k. What will that do? It'll shift the graph 2 down. So here was our graph before. 1, 2, 3, 4, 2, right? This was our graph before. If I take each of those points and shift them, 1, 2, 3 to the right and 2 down, this point, 1, 2, 3 to the right and 2 down, and this one, 1, 2, 3 to the right and 2 down, then this is what our new graph will look like. I don't have to do this. I can keep plotting points until I end up with this shape, but if you can get the idea of shifting, it makes this a lot easier. So the square root of x minus 3 minus 2, shifts the graph 3 to the right and then 2 down. And that's right what we thought it would do. Okay? One more quick example. What if instead of a square root it was a third root? No biggie. See, I can still do 0. The third root of 0 is 0. I can still do 1. Third root of 1 is 1. I don't want to do 2. I don't want to do the third root of 2, the third root of 3. What's the next third root that would be nice? How about 8? What is the third root of 8? So that means all the way over to 1, 2, 3, 4, 5, 6, 7, 8 before it gets up to 2. This graph looks a lot like the other graph. It's increasing very slowly. What's different though? What's negative 1? You're like, not real. That is wrong. Why? What is the third root of negative 1? This time it has a solution. And my next nice point, what would be the next nice third root, would be negative 8, would give me a negative 2, because the third root of negative 8 has a solution. Odd roots have a negative solution. So negative 8 would give me negative 2, and so I end up with two sides of this graph. Even roots only exist on the one side. Odd roots, you can have a positive or a negative x value. We'll also have a little bit of shifting. I'm not going to go too crazy with this, but guess what? The h is opposite, meaning if it's negative, it goes to the right, or if it's positive, it goes to the left. K is positive is up, negative is down. So how would I graph this? Some of you are going to plot points. I wouldn't. I would take these 3 points, and I would shift them all. H, K. This is a positive 2, so that means it's going to shift left 2. This is a negative 1, means it's going to shift down 1. So every point will go 2 to the left and 1 down. I'm going to change colors just so we can see. The 0 goes 2 to the left and 1 down. This goes 2 to the left and 1 down. This goes 2 to the left and 1 down. What does the graph look like? Just like its parent, only shifted. 2 to the left and 1 down. So you got some choices there. Like I said, you could plot some points, but the first section, there's a lot of stuff here that I'm not necessarily going to be testing you to this level. We're introducing it for those of you who are going into the trig and pre-calc direction. Not all A-basket issues. How are you going to know? We'll have a quiz. So get your homework done. You should be very ready for the quiz, and keep it up.